Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be covering 7.2, looking at our trigonometric ratios in a little more detail. If you're just starting on this video, you might want to go back to 7.1 and just revisit what those three basic trigonometric ratios are. We're going to be using those ratios to solve for missing values. So, again, if you need to go back to 7.1, we define sine, cosine, and tangent as sine being opposite over hypotenuse, cosine being adjacent over hypotenuse, and tangent being opposite over adjacent. So using those trigonometric ratios, what we can do is solve for a missing value. If we have any 2 out of 3 of those values, then we can solve for the third using our calculator. There are some cases where we can solve for a value without the use of a calculator, but for now, because we're just introducing it, we're going to be solving for the value with a calculator. So we'll go ahead and jump right into it. Again, you are going to need a calculator here. If you are using Desmos, that's fine. Or if you're using a physical calculator, that's fine as well. Just try to familiarize yourself where those buttons are that we're going to be using. And we'll go ahead and jump right into it here for 7.2. So, in this section, you're going to be given a right triangle. And like I mentioned, you're going to be given 2 pieces of information. You're looking for the third. So let's say that I have this angle here. Let's say it's 40 degrees. I have one side that is, let's say 7, and I want to find the hypotenuse. So again, you're relating the angle to 2 sides using those 3 ratios we've defined, and you're trying to find the missing value. Because the 2 variables or values here that I have for this angle are the opposite and hypotenuse, that would tell me that I need to use my sine ratio. So the sine of this 40-degree angle is equal to the opposite side, 7, over the hypotenuse, which in this case is x. So there's one variable here. This is something I can solve for. This is a cross multiplication problem. So I would cross multiply. I get sine of 40 degrees times x, and that's equal to 1 times 7. To solve for x, then, I would divide both sides by sine of 40 degrees. Once I get to this step, then I'd be using my calculator to approximate the value, and typically the directions will say round to the nearest tenths or hundredths or whatever value it wants you to round to. If it's not specified, you need to put at least 2 decimal places, 3 preferably. So again, I'm going to go into my calculator, and because I'm using the computer here, I'm going to use Desmos, but you should be able to do this on Desmos and on your actual calculator for when we go back in person. So again, try to familiarize yourself with that. Now, in Desmos, if you look down here at the bottom, there's this setting that says radians and degrees. For right now, we are using degrees. Radians are another way to measure angles that are useful as you get into more advanced trigonometry and calculus, but for now, we're going to focus on degrees. So for Desmos, make sure that it's set to degrees. If you are doing this on a physical calculator, at the top of your display window, there's going to be either letters that say DEG or RAD. The default should say DEG. If for some reason at the top it says RAD, you either need to reset your calculator to its factory settings, or if you click the mode, which would be on the top of your function buttons, switch it back to degrees so that it has DEG displayed. Once that's done, it's just a matter of typing it in. So 7 divided by tangent of 40 degrees gives me a value of 8.342. Obviously here in this example, I wasn't given any unit of measurement, so I can just put that value. But if it had said, let's say 7 inches, then be sure to put inches as well in your answer for that value. Okay, that's one example. Let's keep going. So same thing, draw another triangle here. That works out pretty good. And let's say I give this angle as being 35 degrees. And let's say that this side is my unknown, and this side is 12. So I want to solve for the unknown. If I'm given 35 degrees, and really, right, if I know two angles, I could figure out this angle, because the angles of a triangle have to add up to 180. So there are multiple ways to do this. But I would start with just what's given to me, 35 degrees. The two sides that I'm relating are x and 12. So that is the adjacent side, and that is the hypotenuse. So because of that, then if I'm using 35 degrees, I would want to use cosine, adjacent and hypotenuse. So cosine of 35 degrees is equal to the adjacent side, x, over the hypotenuse, which is 12. To solve for x then, I'm going to multiply 12 on both sides, which would give me 12 cosine of 35 degrees. In the first example, because of just how I had to solve for x, I ended up having to do division. Depending on where your variable is at, sometimes it's multiplication. So here I'm just doing 12 times the cosine of 35 degrees. So, again, with a physical calculator or Desmos, I'm doing 12 cosine of 35, which gives me an approximate value of 9.830. Okay. So once the ratio is set up, it really is just a matter of doing the calculator work. Let's do one more, number 3. And I'm orienting my triangles in the same way. It doesn't have to be. It could be flipped or turned around. But actually, just so we're not doing the exact same one every time, let's do that. So say I give you this angle as being 60 degrees. And let's say this side is 5. This side is the value that I'm solving for. So from here, I'm looking at 60 degrees. I have the opposite and adjacent side that I need to relate. That's tangent. So tangent of 60 degrees is equal to 5 over x. Because my variable is in the denominator, this is where I would need to cross multiply. So I have tangent of 60 degrees times x, and then 5 times 1. To solve for x, I'm dividing both sides by tangent of 60 degrees. And then from here, I can use my calculator. 5 divided by tangent of 60 degrees gives me approximately 2.887. And that's all there is to it. Just be sure to set up your ratios properly. If you need to go back to 7.1, write those down in your notes, have those handy. But then just solve for x using your calculator. That's it for today. If you guys have any questions, please reach out to me during office hours. Otherwise, have a good day, and I will talk to you soon. Bye.